yesterday, based on the stats, and I've got sources that I put on here and stuff. Almost $4 billion has been spent just for mining of only 2 coins, Bitcoin and Ether. Now, that's enough to power 5.6 million US houses for a year. That's not the utopian vision. Okay, I think it's sort of an aberration, just as my view on the way the internet started, and I was there kind of early on, and one of the things my company did was one of the first media servers that we sold commercially. We basically developed RTSP, which we use today for YouTube, but it was a thing called the Netscape Media Server. And when we launched that thing, the first calls I got were from pornographers. And it was like a wonderful thing because, it was a way for them to extend their scale and reach their audience. And I think in every early market, there's sort of bottom feeder uses of the technology. That's one. I think arbitrage on coin is kind of the bottom feeder thing. Now, maybe someone in here is rich on Bitcoin, and I say, you're so lucky, God bless you, but you're not changing the world. So I have a point of view. It may make you angry, but it is a point of view. Is it easy? Okay. Everyone gets the point that it's not free, and I'm only talking about a little sliver of the potential, right? Is it easy? Okay, so I've been doing software companies for 25 years. Does this sound like easy to you? I know people in here do hardware and software. This is a quote by the founder of Ethereum. A blockchain is a magic computer that anyone can upload programs to and leave the programs to self-execute. I will tell you, that is not easy. It is not achievable, and it's not easy. It is a utopian dream and an evangelistic pitch so that someone can do arbitrage on their Ether. So take everything with a massive grain of salt. You can see I'm clearly biased against the exploitation and arbitrage of coinage. And it comes through. I mean, but I do think blockchain has massive potential. So what do we need to do to get easy? In each company I've had, the first company I had, one of my major customers was Bear Stearns. And literally, when you click on YouTube today, it goes back to a day when we gave a demo in Bear Stearns on the first video server. It ran on TCP/IP and it ran on ATM networks. My company was in Pennsylvania. I went back later that day. Those days, we had fax machines. And I had a fax machine in my office and a purchase order for $300,000 scrolled across for the InSoft media server, which, by the way, did not exist yet. It was just a demo. And then a couple days later, I got a FedEx from their CTO with Crossing the Chasm, a guy named Jeff Marshall saying, Dan, this book is your life. You better read this. So I read the book and I realized, oh yeah, it is my life. And somebody already lived it. It's not just me. And then I went on to literally work with Jeff Moore and hire him for my companies. But he brought up something that informed Steve Jobs, because Steve Jobs basically worked and hired Regis McKenna about what's a whole product. Right now, the state of IoT and blockchain is not a whole product. It's components that lie around, and it's pundits who talk about, what do you call it? Magic computers. Okay, that's not a whole product. Okay. And this is why I think everyone who's in here is on the cusp of a massive opportunity. So far, you get my point of view? Yeah, okay. Is it secure? Now, when I did the first round of these slides, I said not free, not easy, not secure. Then I thought, that might be a little edgy. So I made it sort of more rhetorical. And this was yesterday. Okay, hackers have stolen $400 million from ICOs. If it's so great, why are hackers stealing 10% of the ICO offerings? It is clearly not secure. And I think that's got to do with one thing, which is in blockchain world, it's called the proof of work. And this starts to inform how we think about it, because I believe a big opportunity exists intersecting blockchain with network graph analytics. So when you step back and you say, okay, in this room in the network graph, we are all individual nodes, and we exist on a graph as nodes. Now we're all here, but we're all interconnected. I think if a proof of work doesn't give you that context, it's highly suspect to a hack and to stealing things. Okay, so can it be secure? Absolutely. Another thing, as I continue to hammer on my utopian vision here, is, if you read this quote, so this came out of, basically it's called the Blockchain Review. I think it's a bi-weekly thing. And it talks about how blockchain works. It says, miners compete to validate transactions by solving complex coded problems. It sounds to me like I'm in calculus class as a senior in high school. It's like, okay, that's academically very interesting. The first miner to solve the problem and basically invalidate it gets a reward. Well, I kind of don't get it. You know, so we're all solving academic problems that don't change the world or do anything. And we put up $3.7 billion of infrastructure per year for computing horsepower in data centers to solve these problems, which are not real. So I think the utopian hammer's hitting the wrong nail. And what I would say is right hammer, wrong incentive. But I think a lot of the coin offerings and token offerings are intended to do this. But I probably see 5 or 10 of these a week where I'm asked to be an advisor or opine or talk to somebody. And I'll give you I just saw one the other day, Mimer. And I know nothing about Mimer. Going to raise $156 million, $56 million for the team. And there's 2 paragraphs in the white paper on the team. And it doesn't say what they're going to do. I mean, maybe I've got some gray, so I'm kind of old school. But when I grew up, you actually had to have something really differentiable and cool to raise money. And I think this technology and this use of it is sort of permutating the whole economy. People think that like they're creating value, but I don't see it. Personally, I don't see it in these particular use cases, which are, I would say, more coin related. Okay. Now, to incent people to create great products and do new things, say, for example, if you raise $300 million and you're going to use some of that money to fund academic research at leading institutions and companies, and then everyone will have a stake potentially in the product, I can see that sort of makes sense, but things to actually just raise a bunch of money. And there's another couple that just came out of MIT also, whereby the money that's going to be raised, first of all, you can't be a U.S. citizen. Major red flag, right? Because that means you've got oversight by the SEC. If you can only raise money in Grand Cayman or Bosnia, don't invest in the deal. I mean, that's my opinion. Okay, so with that, I sound like incredibly negative, but I've been doing this for 4 years, and I'm actually incredibly positive. I just have a point of view that you need to sort of, in an old-fashioned way, build real value. So I call this next part, the sort of second part here, toward the blockchain utopian vision with IoT. Because if you think about whole product, and right now we're sort of like go back to the personal computer in the days of the homebrew club. Many people probably know about this, but this is where, for example, Steve Jobs went with Woz, and they had a wooden case with the Apple computer. That's where we are now in blockchain and IoT. And it's going to take some leading integration to make a whole product, I think, to really take it mainstream. And obviously, the homebrew club are mainstream. And I think a lot of things will go mainstream. Okay, so another more point of view here, going from utopian to pragmatist. So IoT, clearly, I think it's a core component for the whole product. This drove the relationship that our company has with Chris Resendi's company, IoT Impact Labs, because I'll show a little bit of the work that we're doing, but essentially we believe that there should be an interoperable API layer that interfaces to every single IoT device imaginable. And all that data can then be trusted in this context of blockchain trust and proof, registered and then analytics done. And so the data sensing is where it starts. You have to start with great data. So this is why I think IoT is clearly a core component. The reason, if I go back to the 4 years why we've been doing this for Context Labs, this is the reason we exist. And actually, this looks just kind of like blockchain. Our company's designed to reduce friction in the supply chain. And it goes back to another point of view. The way I think about the supply chain, I think it's a supply chain of everything. So like an idea is part of the supply chain. And if you're in a company now, your idea may go into a wiki internally. It would go into engineering documentation, patent disclosures and stuff. And then it traverses all the way through productization, to marketing, to customers, consumers, et cetera. There's a lot of friction there. And I also think there's an anomaly in the current internet, because in the middle of that supply chain exists a category that we now call super aggregators. So like a super aggregator is sort of Amazon, okay? For the life of me, I don't understand why Amazon takes 55% of a bookseller's revenue, and all they do is take the order and ship the book to your house. Don't get it, right? So the super aggregators, I think 20, 30 years from now, we're going to look back and say, how in the hell did that happen? You know, and similar to Apple. I mean, I worked with Apple early on. I've loved Apple. I'm using a Mac. But when Apple basically came forth with the App Store, they take 30% of the revenue of all software. Completely transformed and disintermediated the software business. I don't see the value they provide. This is where I think blockchain is critical, because blockchain can reduce the friction and you don't need them anymore. Now, I know Amazon's been, or Boston area has been shortlisted for Amazon to bring a lot of jobs here. I think it's the worst thing ever for the economy, because I think ultimately, as all huge companies fail, companies that have actually exploited their position in an unfair way actually pay a price. You know, look at great companies. DEC was a freaking great company. They're not here. I love Sun Microsystems. Where'd they go? You know, I would hope to say in 12 years, Amazon, who were they? Because the net reality of a company like that is we have less choice. It may be cheaper, but you know, I'd rather have better choice and maybe pay a little bit more or the same. I think what this technology can do is reduce the friction so you get more choice, like the rising tide floating all boats. Sounds kind of radical.
I like it. I've been saying it for a couple of years too, so I'm with you.
Everyone think about a company they loved that no longer exists. A big company. Polaroid. What a great company. Okay, so
Netscape.
Hey, I lived it. Yeah, and also I will say about Netscape, Netscape kicked off what was basically called the internet bubble. But the reality is we actually had technology, and we still use it every day today. And when the company sold us for $10 billion to AOL, I think if I think about what some of the blockchain companies are, I mean specific to coin, I don't see what it is. You know, I mean, it's a method and a process, maybe. Great point on Netscape. I mean, and I think there are a lot of lessons to be learned, and that's, when I was there, it was the fastest growing company in the world. Mm-hmm. It was the coolest company in the world. And then 3 years later, you know, it was gone. So these things do happen. I could do a whole course on this, so I don't want to talk about it anymore. Okay. So this goes back to my thing about the supply chain of everything. Everything is your idea all the way through. Okay. And one of the things I think about IoT and blockchain is you can get intensive granularity. You can go down to literally the moment in time that the inventor posted to the wiki in this company and record that in a context, which was his department or her department, the company, the location, the partners. That's immutable. And that's where I think the granularity goes all the way from ideas all the way to when you actually get the product at your house and maybe you've got a scanning app and you scan it. That's why booksellers are using our technology now, as an example. Because when I talk about a super aggregator, for example, Amazon doesn't tell any of its suppliers who its customers are. So if you're Random House and you're selling X amount of books, you don't know who your customers are. And I don't know why people think that's okay. And I think it's time, to do something about it. And that's why I'm working 4 years doing this, because, you know, it's a permutation of what the internet vision was, I think. This idea that everything is interconnected. Earlier I mentioned the nodes and the edges. Well, everything is also interconnected, and everything that happens creates a state. And in blockchain speak, that's a ledger event. Okay, and every ledger event has a timestamp. So once again, granularity, 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 which you can derive the data from IoT sensors as one form of data. Okay, I'm kind of transitioning to how our point of view has manifest itself in our platform. Our platform's called Immutably. And what we intend to do and what we are doing here is instantiating this Internet of Things. And things are everything, right? It's physical things, mechanical things, electrical, connectivity. It's digital. It could be data. It could be sensor data. It's physical. It's a thing like an embedded module in a car that has a bunch of sensors in it, that has firmware in it. That's physical and digital. It could be a virtual model. For example, 3D models and simulations can be produced. Those are also things. It can be cyber assets. So this is where I think the IoT thinking merged with the tool that is blockchain helps create this granularity so we can track things through time. Okay. This is when we talk about, so why is our company called Context Labs? It's because we believe that there's a context for everything. And that context is what I call the who, what, when, and where. Okay, so right now a proof of work is pretty much just a when. Okay, that's not very interesting, and you can't do a lot with it. So if you bundle these things together, which is what we call contextual proof, then you can get what the evangelists and the utopians call truth. Because you hear a lot of blockchain enthusiasts and evangelists talk about how it represents truth. I think if you just register something simple, a nodal piece of data, that doesn't represent truth at all. Truth is always in a context, So what we tried to do is build an API that can extract this data from many sources and bundle it together in basically a digital object, which could then be proved that it's got a hash, can be registered. Once again, tracked at the granular level. All the components come together. Okay. And then all these states, they have a connected context. So an example, even though I love Apple, I use an Android phone now, but I'll pretend it's an iPhone. and because everybody knows Foxconn makes the iPhone. So massive distribution share for all the products that are in a phone. Devices actually have little microkernels running there's multiple operating systems. Right? These things all come together into the supply chain, into modules that then get assembled. Right now, how can one know that someone hasn't put a hack in there? You cannot know. Everyone is at massive risk right now. So this technology, using IoT concepts and technologies, can literally go right to the bare metal, into the firmware level, and register what's together. And then if anyone who's worked in manufacturing, ultimately there's a bill of materials. What's the granularity of the bill of materials? For example, I think blockchain transforms PLM systems, product lifecycle management, because it actually tells you in an immutable way what should be in this bill of materials. There's no way to know that right now. There's no way. So that's the connected context, if you think about that. How are all these things on here actually related? And what's the digital connection? And you could do this. I sold a company to Oracle. There's a thing called Oracle Fusion that basically my company was the first company that they bought my company to do Fusion. You can do all this in a database. And I think it's quite interesting that Oracle hasn't really offered blockchain services, but I think they'll wait, and then they will acquire the biggest player. Also interesting, I'm going off the tracks here, but another interesting thing is the biggest competitor to Oracle is IBM with their database system, and IBM is flooding the blockchain like crazy. But just think about what the blockchain evangelist has to say about distributed ledgers. I fail to see why running a blockchain implementation on large mainframe Z servers is a distributed architecture. So things are confusing. That which looks distributed is not. Another thing, I mean, as I ponder at night when I can't go to sleep, I think, man, all this stuff, probably 80% of it is running on AWS. Shit, that's Amazon. So understand, like, every system has a root super user person. There's somebody like that at Amazon too. So I would be really afraid. That's another reason I think the super aggregator needs to be taken down. Okay. So real, true distributed systems. I think the internet is designed for this. Like, why was there a portal? And when I was at Netscape, I remember when Jerry Yang came in to pitch us on Yahoo, and I remember thinking, a portal? The internet's distributed. Why do we need to all go to your site? We go to everybody's sites. And I think blockchain has that inside of it, but I think there's a market trend that always wants to aggregate it and be the big dog. This is just another graph showing what I call a multi-point contextual proof. This is how it works. So instead of the takeaway you should get from this slide is it's not a node. It's a node and an edge, and all those interconnected nodes and edges. And a single chip in your phone has a multi-connected network graph of the designers, the engineers, the manufacturing, the materials, all rolled into a bundle. Maybe go back to Apple again, which is in the Foxconn supply chain to get placed on your phone. Okay. My point about going from utopian to pragmatist, I think the way you get there is it's a component. This is the way we think about it. So these are the technologies we use in our platform, and blockchain you can see is one of them. We haven't drunk so much Kool-Aid that we want to just sell blockchain. Because I think blockchain is like getting really excited if you're a car manufacturer that I'm going to give you a toolkit with a ratchet. It's like, what do I do with that? So in terms of like how we intersect, and this I struggle with this to come and talk to this group because it's IoT. And I think IoT is an enablement of blockchain. When they come together, maybe one of the takeaways for what I'm saying is the whole product. Right? It's a componentized view. Okay, so I've got just 3 more slides or so. We've been building this company for 4 years, and we've got some pragmatists. Enterprise customers are all pragmatists. It goes back to the crossing the chasm, the early adopters, the mainstream market, and the pragmatists are the guys who wait. As a philosophy, I generally try not to go after early adopters. I prefer to wait to spend more time and try to get pragmatist customers to get big deals rather than a whole bunch of little ones. So I've got some examples, and basically we've got an implementation. Think about what is the most analog thing you can get. The book, it's like it's still in our hands. It's paper, and this also impacts my point of view on the super aggregators. So from our point of view, is who's a first customer? Well, probably the company that prints all the books, right? So we went out and we established a relationship with a leading company called R.R. Donnelley, who prints, almost 1 billion books a year. And in a very pragmatist way, blockchain and IoT technologies are embedded in multiple factories, printing millions of books. So this is doable. And what this does is it allows their customers, which are all the publishers, to get their books printed. And essentially what it's doing is making every book digital, which is so super cool. You take the most analog thing you can buy, you put an encrypted, unique hashed ID on the book, and print 600,000 of them. They all have a digital twin now, which is registered in the blockchain and proved. Okay, so this is a way to, if you think in the supply chain, so I'm writing the book, I go through, I get it manufactured in this facility, it gets distributed, I buy the book, I probably bought it through Amazon. I mean, even I buy stuff through Amazon, and every time I do, I hate myself. So when I get the book, I can click on it, and that'll take me back to the publisher. And then if you're the publisher, you know who I am now. Kind of cool, right? Now I'm the publisher, I can market to you, and guess what? I can give a bigger discount to you directly than Amazon does because I don't have to pay them 55 or 60%. That's how the super aggregator. I won't say anything worse than I've already said. I shouldn't have let you stream this thing. Okay. Okay. So 2 more examples that we've done. One is think about the most analog thing, and then think about the most digital thing. You know, basically data. So there's this big concern about, you know, fake news, fake data, et cetera. So we thought, let's point our system at massive gobs of data that has to do with the environment. So what we did is we partnered with the Environmental Defense Fund. And this is actually how we met Chris, because we had done a project before this to essentially build this massively deep data set on fracking in North Dakota. But what we've done is we partnered with the EDF now to extend this to the world. And the idea is to build the world's trusted source of environmental data. Now, think about the whole product again, right? How do we get data? Sensors. Basically, an embedded system mounted in the field, and then data sets. So what we've done is then bring that together to provide deep analytics. So in the EDF, we'll be announcing this, you know, in the next 30 days. We've been working on it for quite a while, where you can not only do descriptive analytics, but you can actually run models against it and say, if regulatory practices were changed, here would be the impact. So it's literally a tool. What it's doing is it's coupling IoT and sensors with blockchain, with network graph analytics, with visualizations, so you can do something with it. So it's, you know, like we're sort of limping towards whole product. You know, it's like no one ever like gets the whole product right out of the box. Steve Jobs never did either. You know, think of the Newton, right? That thing totally failed. Bunch of stuff fails. So this is an example, analog, digital. This is actually what we're trying to do with the EDF, and this will be on their site, but you know, some quotes here on what they think about it. It changes the narrative. The industry owns the narrative now. Now, people who live on the planet can change the narrative because they know what the data looks like, right? One more slide. So we've done this for music publishing too. Context Labs was the founder, really, and we did this with Berklee College of Music and IDEO for something called the Open Music Initiative, the OMI. And right now there's about 300 members or so, a little more actually. And what this is about is literally providing kind of the data stream such that a blockchain system can leverage it. So if you think about like ingesting data for books, we're ingesting all the book data. For the environment, hundreds, thousands of data sets we're ingesting. For music, all the music that's ever been composed and written and published. Once you can ingest that, then you can actually get people paid who wrote the music. So once again, it's sort of a way to disintermediate the super aggregator, you know, but in this realm, for example, super aggregators had to sign up. Like Spotify, as an example, you know, claims, I think at the time they signed up, they owed $150 million to somebody, but they didn't know who, right? So this is why we did this. So these are the 3 main sectors. Just as a summary, you know, I struggled to sort of intersect what we're doing with it's not a pure play theme for what the MeetUp is, right? But I tried to show how IoT matters and how blockchain, when you integrate these whole things into a whole product situation, you can really move the planet, you know. And, I think everybody here working on IoT is doing that daily. And once we start building interconnected systems, we're going to get there. So this is what I
Thank you. Questions?
Do you see the role of PKI being in a blockchain world? Do you see that people are going to implement a PKI on a blockchain, or do you see that blockchain is going to replace it?
I think it would be integrated. I don't see what's the compelling need to replace it. I don't really see it. Yeah.
I think there's going to be people are still going to have a PKI implement it on a blockchain and they're just going to make the certificates on a public ledger. I think that's what's going to happen. But
it's possible. I mean, I also think one of the things on the slide I had here about, I'll show you here, back a little bit. Anyone who's actually done software companies and sold to the enterprise, let me go back, I'm sorry. Sorry about this. You're going to see every slide now. It's this one. Okay. And this is the magic computer slide, right?
Yeah.
And it says always publicly visible. So the company that I had that became Oracle Fusion, they've got 75,000 customers now. So in my career, I've sold to probably 100,000 customers, corporations. No one has ever wanted their data to be publicly visible.
yeah, no, right.
Okay.
Right.
Nobody. So like this idea about the permissioned ledger.
Yeah.
I think, and IBM's got it right on that with Hyperledger. The permissioned ledger is the way to do it. So maybe you instantiate that in the permissioned ledger. But the public thing, I'm just not buying it. And we sell to enterprise customers now, and no one can figure out why it needs to be public. And why do you want sort of random people, the gamification of mining for something real, where if you and I already have a contract between our companies, we know it's real. I don't need some kid out there hacking out.
The hackers also, right? Where
Yeah.
people can see everything and then they can figure out how to work around it.
Yeah. So that's, once again, utopianism to pragmatism. Yeah. So pragmatic is probably not everything public.
Yeah.
And, maybe I think it's exactly like you said. And for some purposes, you may want it on a public ledger.
Right. Other cases, you want it private and there's no need for everybody to see.
Yeah, it totally depends.
Yeah. Okay. Thank
Rob
you.
Black.
How are you doing blockchain at scale?
Well, I gave a couple examples here.
Well, no. I mean, like literally how? I mean, if you look at, for instance, some of these coins, the resolution time is measured in minutes. With IoT, if you have thousands or millions of sensors, I mean, I don't really understand how you could
The
resolve.
resolution time is because of mining.
Well, okay, and then from a blockchain standpoint, like how distributed is your ledger? Like, I guess the challenge I'm having is, let's say you have 1 million sensors in the network. Are these ledgers immense? Like who's holding all this data? It just to me, it seems like it's a very difficult thing to actually do at scale commercially.
It's the same as 1 million books, though.
No, but it wouldn't though, because the sensor data. I mean, think about what's coming off these sensors. Hold on. No, hold on. For IoT, when you talk about sensor data, I mean, you could have terabytes of data for a day, right? I mean, like
Automobile.
What's that?
I think about an automobile.
I mean, just it's tremendous. If you're talking about environmental
Oil and
sensors,
gas, another example.
yeah, I mean, it would be absolutely immense. So thinking that you're going to be able to resolve this in a blockchain ledger, I mean, this thing would have to have demonstrate many orders of magnitude improvement in scale.
And that's already happened. I mean, I think in enterprise blockchain implementations, things that aren't necessarily published, you're probably seeing easily 1,000x over what you see.
But I think you're going to have millions of X for IoT. I mean, for IoT can be, the data is just immense.
Here's another way to think about it. So data now that's streamed into a real-time, like streaming database, this will be faster. You won't have the overhead of a database. So there's like this big misconception, I think, that blockchain's a database. It's not a database. It's how fast can you read and you write? That's how fast it can be.
It's a mechanism.
When people say we're building this blockchain database, I always say, well, I don't think so, because where's the query language? It's totally distributed. How do you actually back up and do rollbacks and do all the stuff that a company like Oracle does? So maybe the way to think about it, this is a really complex question you asked in the menu, by the way. The way I would answer it really is to think about how fast can one read and write.
I think it's very difficult, and in general, it's very difficult to keep up with IoT data at that scale, regardless of technology. And blockchain has a lot of overhead because you're distributing that data in all these different stores, and then the storage cost is going to be immense. I mean, if you're talking about environmental sensors, right? If you're talking about some enterprise application, maybe it's more realistic.
Well, I think another answer to the question is Moore's law. You know, like if you roll back 10 years ago, what you can do on your computer versus what you can do now. Ultimately, throughput and horsepower is solved in silicon. So that's part of the answer. Another part of the answer is maybe not every particular application that's streaming data that fast is suitable for blockchain.
How does it do with the digital music?
It's not a one size fits all thing, right?
The music's much bigger. I mean, an MP3 is much bigger than a block. Than it's block. So how's that done? I mean, they just do a cipher, a hash on the actual content, and that's what's blockchain. They don't. There aren't
you don't ingest like a whole massive
the
file into the blockchain.
Exactly.
That's what a proof is. So a proof is an instantiation of a piece of data, and so the contextual proof could have like 10 different things related to it, all rolling up into one hash. So the read and write of that hash, it's not the whole MP3,
right, so
it's the hash
that
representing
there you have a finite piece of data with IoT data. Let's say you're doing sensor reading, temperature reading, let's say even once a second. So something that's not, right? So you're reading that temperature data. What are you hashing at what point? Because there's no, like unlike with an MP3 file, there's no, next second the hash is not really that valuable.
I think it depends, what the application is. And so I'm basically, I'm a pragmatist, right? Sort of the takeaway from my talk is a total pragmatist. If I was a true evangelistic utopian, I'd say, we hash every single data point. I don't think that's really what you do because of the same thing you're saying. You can scale out pretty fast if you want to be as discrete and granular right now with the state of even the bus. So we're working with and had meetings with all the major automotive manufacturers. They all have efforts on blockchain. And all the efforts have to do with autonomous mobility, a lot of them, which is a lot of sensor data, right? And one of the throttle points is the actual bus in the car. And the bus actually can process the data. So, it's not answerable, I don't think, right? There's a lot of research on that. Okay, question up there.
I'm wondering how you're implementing. I'm assuming, like in the 3 projects that you use as examples, you were implementing private chain. So, like, were you working with, say, Hyperledger, or were you like, did you guys decide something like this in-house? Like, how are you addressing issues like, throughput, Byzantine fault tolerance, issues like these?
Yeah, we're designed to sit on top of a fabric, right? Such as Ethereum, Hyperledger, and we actually have our own fabric also that we call Scrivener. And the way to think about Scrivener is it's sort of like the JDBC for ledgers. So companies could actually implement another ledgers and still have interoperability. But that's been our architectural approach to it.
Right, and then in designing these systems, were you did you guys have to innovate in overcoming the challenges in, say, proof of work or proof of stake, or because even though proof of work is proven to be not very economically viable, you still have to have some replacement for it, right? So I'm wondering if you're at freedom to disclose.
Not really, I'm not. No. I did talk about philosophically what we're doing though in the contextual proofs. So think of the summation of various proof mechanisms, all being discretely done and then rolled up into like the sum of the proofs rolls up into what we call the contextual. That has its own hash too. The granularity goes down to each individual one. Now, what we've done is, software is not like this monolithic thing, right? You learn as you go into different customer sets, right? So, our platform, the current state, has been informed by the customers we have and where we're targeting. So, we just announced the deal with Chris's team. That's really to help us think more deeply about how to architect into IoT to sort of answer your question too. And to learn more about it, because no company has all the expertise in that. So that's where we think we're going to be going. And if you look at like what we've done with the EDF, that's a component of it, because they basically have funded projects for in-field methane sensors, for example. So it goes to your sample rate and everything else. So that will inform our API on how we ingest all that data.
Yeah, didn't you talk about going upstream, and IoT Impact Labs is kind of part of that? I mean, can you talk about kind of strategically what you mean by that?
Yeah, it ties into the Jeff Moore stuff. Not the whole product stuff, but Jeff Moore talks about what he calls the bowling pin strategy. Everyone, if you haven't read Crossing the Chasm, you got to get this book. It's a book that was FedEx to me 25 years ago, and it's still relevant. The bowling pin strategy is, you in a segment, you find a customer, and you satisfy that customer. That helps you on the path to the whole product. And then if you can satisfy that customer, that's the bowling pin that falls over and gets all the other customers. So that's one way to do it. Sort of a permutation on that we did was to say, let's look upstream. So when we wanted to do the book thing, we thought, okay, should we go out and close 260 different publishers? Or should we go upstream and find the companies that print all the books? So I think the further upstream you go, the bigger market share you can get. But it may not be the right thing for maximization of revenue. But if you want to sort of get installed everywhere.
Fewer customers.
Well, more customers actually.
Huh.
But you've closed them all in one deal.
Right.
Because, in technology companies, building a sales force is probably one of the most expensive things. So it kind of gets into channel strategy. There's direct, which is like in this model would be direct. We would call on every single book publisher. An indirect sort of OEM strategy would be to go upstream and find out who they all use to print their books, as an example. So that concept can be applied towards a lot of different things, right? But that's the general theory, and strategy that we use.
I think I interrupted somebody else's question. Behind you.
Yeah, just a basic question. Dan, what is a proof? In your context you described using it?
Well, there's different kinds of proofs, right? I mean, you could define new proofs also. There's like a proof of existence. Here I am, I exist, sort of like hello world. And if you can get that, another thing about going upstream is that's when you can establish the provenance, right? So if you think about firmware in an embedded system in an autonomous vehicle, radically concerned about can the vehicles be hacked, right? So if you go upstream to where the chips are made, proof can be about literally as the device comes off the manufacturing line, you establish its existence. And that gives it a cryptographic hash on its existence. That's one kind of proof. Then there's what we would call the contextual proof, which is what's its context? What other parts are around it? What systems does it go into? What other companies provide the components into the subsystem?
So it's identity, authentication, and context.
There's different ways to think about it, right? So there's no one way. I think in standard blockchain speak, it's talked about more as like, as we said earlier, over here, a proof of work, right? It's a kind of a different thing. One of the things we look at for a proof is the attestation of the thing. The thing could be a digital or physical object. What we're trying to do is build an API so the customers can establish and define their own proofs. So out of the box, things that are relevant to the customer, that becomes their proof. The proof, and maybe the way to step back is say, we don't want fake data. We don't want fake news. We don't want fake products. If you were a company that was making something, say that was being counterfeited, what would matter to you for the proof of that product's, say, provenance, its authenticity, and then its veracity as it goes through the supply chain. Each one of those points in time, you can establish a proof to sort of ensure the chain of custody.
When you say proof works, what do you mean?
That's just our product modules. Like we basically have 2 product modules. Well, 3 really. One is called Immutably, one's called Proofworks, and one's called Impact Analytics. So the Proofworks in our system, the way things work is on the ingestion of data, whether it's data sets or sensors or whatever, essentially that data will all be proofed before it's ingested. So when I say ingested, it goes back to your comment about MP3s too. The system doesn't ingest the data. There's no like super aggregator of all the data. But it does know about the data, where it's from, and so you can prove that the data is the data.
So it'd be like a checksum for something from the file, or
Just
just a file name.
Well,
If it's the original artist,
no, because the system can detect, say for example, you have this, you just copy the file name. It can look at like the byte signature, for example, and know it's the same file name, not the file.
so a checksum, something that is effective and
At,
mutable.
at a byte level, yeah, like a byte signature or something.
It's complicated. Don't be afraid. I ask dumb questions.
You'd be
all
kind
the
of afraid though, because because our CTO Gavin Nichols is supposed to be here, and I'm about ready to be pinned here. So, so I'm gonna cry uncle like when I'm pinned.
So it would be like a primary key in data in a table, in a database, the ID. Just something that would identify the class, if you will.
There could be a bunch of them though, right? And it's an kind of goes to the core of what cryptography is. Even if you looked at it, one of the beauties of blockchain is if you looked it up in the table, you still wouldn't know what it is, because you could only look up the cryptographic signature of the thing, and you still wouldn't know. So,
But you would know that it exists. That exists somewhere, and you would get the properties of that hash somewhere.
right, which is why it's not a database. I mean, I basically have theoretical arguments with so many people about this, and I can see why some people think it's a database, but like if you ever worked for a database company, like I did, like Oracle, it's not a database. So the concept, I think that you're saying, conceptually that's it, but the string of characters that's in that field is maybe the way to think about it. It's obfuscated. It's even more than that because it's encrypted. It's an encrypted signature. So you still wouldn't figure out what it is. See, once again, it's not easy. It's totally not easy.
Question here from Andy.
Is the lack of security standards prohibiting the adoption curve of IoT?
So I've been an entrepreneur that starts companies, and I think a barrier to having cool companies is standards. So my philosophy on doing companies is you create something really cool that everybody uses that then becomes a standard.
Mm-hmm.
So like I would personally never start a company that tried to write to standards. There's stuff that's sort of de facto that you use, but I think if you want to innovate, like since I've met Chris, we talk a lot about NIST standards and stuff like that, and I'm kind of thinking like, well, by the time we get a NIST standard, like we're going to be dead.
Our opinion would be no. The lack of a singular standard or a set of harmonized standards in security and IoT, we don't think is a material barrier to investment or scale.
And to Dan's point, often the victors write the standards, right?
Sure, absolutely. Yeah. De facto or otherwise.
Right.
It's the old Scott McNeelyism, market sets the standards. That's been my experience in doing companies too. Like when we look at RTSP is a standard that came out of getting lots of people to use a certain format of video, which effectively, the way that became a standard was, you had to go through the ITF process with RFCs and stuff, but all the people who sat on those committees were the companies who had the biggest vested interests, So if you're a startup, it helps to be an influencer so you can sort of get deals with bigger companies so they'll sort of carry your torch for you.
So in terms of like IoT use cases, and this is probably going to echo some of what Rob asked as well, and like kind of helping us to understand where this type of technology might really be useful. My sense, as probably like the least technical person in the room, but that depending on the IoT application, let's take like connected car, there's going to be real-time data and real-time decisions that need to be made locally and that need to be made with, basically zero latency and zero, overhead, real time. And then there's a whole bunch of data that maybe is going to be sent back up to the cloud, and that, where you can tolerate latency and where the value of the data is much higher, right? So like tire pressure sensor or brake sensor versus all the telemetry from the car about how it's operating and where it's going, who's driving it, and everything else. Where would this technology, do you think, be in, like, if we were to take the connected car as a use case, where would it be most applicable, and where would it be like, okay, this is just not right?
Well, the auto companies have come together, and I'm working with basically most of the companies except the Korean companies, and they've actually jointly written 10 or 12 use cases for the use of blockchain for cars. Mm-hmm. All these questions that everybody's bringing up about, when you said the word real time and latency, it always comes up, right? Because real time isn't really real time. So we talk about real time streaming protocol. It's not real time. Says
the guy who created it.
Well, even when you get like with really specific, massively intelligent electrical engineers, there's a definition of real time that exists, and then there's sort of a market understanding of it, and they're two different things. So like every time there's a real time discussion, I always sort of like try to step off the gas a little bit and say real time is a function of what the application needs. So
like if you have some actuator or something, right? So there's, depending on what it is, there's some level of latency that's allowed for that particular function. That's
the gating factor is the hardware, I would say. So like the software, like when we talked earlier, I mentioned about microkernels that exist on our devices and we don't even really know they exist. People don't know this, right? So, so I don't think the software is, maybe a way to address the question is like, I think it's a hardware design issue, which that will address the real-time latency issue. For example, the bus architecture in an existing car, or cars that are being designed, it's got to be designed, for the question back here, for high throughput, low latency, like zero latency essentially, or else someone's going to drive and hit somebody, Mm-hmm. And that's where the standards come in too, right? Because I really believe that it's dangerous sometimes for like the industry to get so in front of the standards. Mm-hmm. For things like cars and things like that, people get.
Are the 10 to 12 use cases for blockchain being developed by the car companies being developed in an open group, or is it just you and them?
Well, actually, there's a website. I don't have it off the top of my head. I can send it to you. Mm-hmm. And people can join. There's a consortium that's being put together. There's a website for it. It lists the companies involved, and has some of the use cases.
Do you know what the name of the consortium is?
Not off the top of my head.
Okay.
Once I'm out of the flow of the
meeting,
send
it to me, and I will
send it out to everybody. Excellent.
So just make sure we
follow up.
Yes.
I won't let you flake out.
Can we get the slides also? That doable?
Yeah, I guess. Yeah.
We can send an expurgated deck if you
drive a hard.
Well, the slides don't say anything about the super aggregators, though. Yeah.
Right. Yeah. That's a problem. You might have to add those
later. You have
later.
to come to the show to hear that bit.
About how you want Amazon to crash and burn.
Is there a question back here?
Yeah, you mentioned the bowling pins just now. I was wondering, I guess, what are some of the prerequisites to getting that first bowling pin? You said that you've been working on this for the last 4 years. What has kind of changed and improved during these 4 years, and what else do you need to do to get there, you think?
You mean for this particular segment, like this intersection of blockchain with sensors and network graph?
I guess so, but I'm also interested in the broader application of blockchain in other sectors too.
Yeah, I think it's the whole product thing all over again. Like, we were able to develop an at-scale platform because we understood the needs of a big customer. You know, like sometimes I also believe that customers never know what they want, never. And your job to be
They know what they need. They know what they want.
They never know. I mean, so I think the job of the great entrepreneur is sort of intuit what you think is cool and show it. And then, you know, if you get smacked down, back to the drawing board. But like often if you're sort of intuitive, I think you can bring your step towards whole product. And then if you can get the customer engaged, then I think you start iterating, you know, the whole iterative process to make the cool product. It does come down to the whole product though, because like and this is like a big question, which is how you actually do a company, right? How do you do it? And you know, we have certain kind of rules of thumb that we use, and there's the old demo or die kind of thing. Like, I believe if we can't demo in real time, like minimally once a week, then we're already dead. So like, we have to be able to like evangelize each other before we can evangelize somebody outside the company.
So I guess more concretely, would it be kind of the scalability of your solution, kind of the transaction speeds, or what is not ready to be demoed yet?
Well, I can give you an example. So one of the innovations we have is the intersection of blockchain with network graph analytics. That's something new, and precise, specific demos can be built with that, with really cool visualizations. That's what I think customers respond to. It's like, okay, how can I understand my supply chain better? And if you give them different views like that, I think that's how you learn. And, you know, that's why I think the 10x engineer idea really matters too, you know, because I don't think you can like put it in a market requirements definition or a spec. I mean, to me, the coolest stuff that happens is like somebody on the team does an all-nighter and you come in the next day and they just blow you away because they got a cool idea. Like, that's how I think stuff gets in front of customers, with people doing stuff like that.
Okay. I was also actually wondering, do you think blockchain has any value as a financial instrument?
Absolutely, yeah.
Yeah.
Totally. Yeah.
Just as a sort of value or kind of transactions, I guess.
I'm just sort of anti-fraud, you know? Like, okay. I believe, I mean, everybody knows this, like the overutilization of ICOs and token offerings and stuff. Just go read them. I mean, you don't have to be an expert to read a lot of these white papers to see that there's not a lot there. But as a construct, yeah, I mean, totally important, I think. Yeah.
Yeah, I think we have one more question, and then we're going to turn into, our carriage is going to turn back into a pumpkin. So
I have one very basic question. So for the IoT platforms, in my mind, maybe it consists of like a millions of like a resource constrained devices. So I'm just wondering, so who is actually responsible to compute these blockchains for all those networks, and how could this blockchain get shared by all the devices in real time?
Yikes. The framework I would look at for that is the enterprise permission to blockchain. You know, so the use of IoT technology in the supply chain. So one of your questions is who's going to pay for it?
Yeah, who's going to compute actually? Because, if, for example, your phone has very limited batteries. It's not or impossible for you to compute all the blockchains for the entire networks, right? So if you have millions of devices and you need to update those blockchains every second, every millisecond, stuff like that.
I think a lot of the scalability comes off side chains. So if we did the supply chain solution we were talking about, where we use the iPhone with Foxconn as an example, it's literally got to be, that is a connected graph of blockchains, yeah? and it's decentralized inherently. Like, you know, you don't roll it up to like one massive server that's doing all the crunching. Yeah, it's massively distributed.
Are you saying, in other words, as close to the point of inception of that digital thread or digital identity, distribute the processing of the architecture so that there's no bottleneck in any one of those supply chains where all this processing needs to take place?
It's an architecture question, you know, and you know, maybe the way to think about it is, it's by nature, blockchain's distributed and decentralized. So in some ways, that looks like in the old computer architecture language, like massively parallel, right? So I'd say the more you push to the edge, the endpoints, like that is what you're saying, I think, Chris, right? As it's pushed to the endpoints, that's the best place to keep it.
Well, the data tends to be simplest at the endpoint. Context tends to be most specific at the endpoint.
Locally.
Yeah.
Yeah.
And maybe not on board a resource-constrained device, obviously, but maybe on a gateway that's ambient to that resource-constrained device. But I think, to Dan's point, you know, think architecturally about the digital network, think about the workflows, the architecture of the workflows, think about the architecture of the transfer payments. I mean, there are multiple flows that need to be considered, I think, in order to come up with the right architecture for how to stand up these tools.
Okay.
I don't think there's one size fits all, and I certainly don't think it's looking toward a centralized authority in any given or specific supply chain.
Yeah.
These questions are all killer questions. I mean,
Yeah.
and each one
Boston,
of these,
baby.
each one of these questions is like, you know, a whole day meeting. So like, I'm not trying to be flip or anything because I know people have questions, but
This happened when we
very
did,
killer questions.
This happened when we had Fitbit's team come and talk to us too. They were like, "Who are these people? Like, what's going on?" They were spooked. They were visibly spooked. So it's a
So I'm just doing my best, you know.
Yeah. So do you want to give us a parting shot? Like, I mean, so you came in and asked a bunch of really hard questions, but you also said you're an optimist. You're clearly invested in this. So give us your optimistic parting shot. Why are you up so much? Why are you spending so much of your valuable cycles on this? If it's not free, and if it's not easy, and if it's not yet secure, why are you picking such a hard problem?
Jeez.
Boy.
Well, everybody's here, right? Everybody's here for a reason too. I mean, you have a purpose in your life. So it's almost like it's a Tony Robbins question, you know what I mean? But I don't want to go there.
Oh, God.
But everybody's got a reason for their life, and I have a reason for mine, you know? I like inventing stuff and solving big problems. You know, that's why I'm doing it. That's what gets me going. The fact that it's not easy, you know, and all these things that I mentioned before, actually, those are the things that sum up for massive opportunity. There's a massive opportunity. It's huge. You know, even if you look at, you know, I think even some of the, you kind of know my view on coinage, right?
Sure.
I've made my case. It's that market in and of itself is huge. To me, that's no different than me being approached by pornography purveyors from the Netherlands in 1996 to buy our media servers. If I look at the business on the internet now, it's minuscule. So that's where I think the opportunities is. So, like I said, I know it sounds really derogatory, but I think every application or every new technology has sort of like the bottom feeder stuff happens first because they find a new way to sort of exploit something. You know? I think that's what's happening now. I think the true utility comes through later. I mean, if I just go back to the video server thing, I mean, heck, back then no one envisioned YouTube. You know, no one envisioned FaceTime on everyone's phone, and we had that in 1993. So it's like that's what gets me going. It's like knowing like if you're working on something significant that can work, and there's risk too, right? So some people are more into risk than others.
Funniest reference to Bitcoin I heard today was somebody called it the Dunning-Krugerrand.
Dan, thank you. I know you're
Thanks
crazy
very
busy.
much.
Dan, thank you very much. Wonderful. We steamed up the windows, which you don't usually do at a meetup. Thank you so much, and thank you, Chris, for suggesting this and making it happen.
Thanks for having
the
us.
IoT.
Thank you.
Thanks, everybody.
Oh, that's great.
So I introduced myself. I was managing QuickTime at Apple when you were doing your video server.
You know what? We had